Finding trig values. We're going to need to find the remaining trig values when one function is known. All right, what do? You determine the quadrant. Draw a unit circle and label the given sides. Using Pythagorean theorem, determine the length of the missing side. Recall your Pythagorean triples and determine the unknown trig values. Okay, sometimes you may not have to actually draw the unit circle. You can just actually draw the triangle in that quadrant. All right, let's take a look at number 1. But before you do that, pause the video, copy down the directions, and then come back. All right, now that you have that copied, let's take a look at example number 1. If the sine of theta is 5/13 and theta is measure of an angle in quadrant 2, find the values up. All right, so we're in quadrant 2. So we're actually going to draw ourselves an x and a y axis. We're in quadrant 2. Here's theta. All right, it said the sine of theta is 5/13. Sine is opposite over hypotenuse, and hypotenuse is here. So I'm going to need to find the missing side. Oh, it's a Pythagorean triple, so it's 12. But what kind of 12 is it? Because look at the position of where it is. You're correct. It's a negative 12. All right. Now that we know that, we should be able to find all the trig values. So the cosine of theta is negative 12/13. The tangent of theta is 5 over a negative 12. That's negative. Cosecant. Cosecant is the reciprocal of, anybody remember? Sine. So if sine is 5/13, cosecant would be 13/5. Secant is the reciprocal of cosine. So if cosine is negative 12/13, secant is 13 over a negative 12, or you could actually put the negative on the top. It doesn't make a difference. Cotangent is reciprocal of tangent, so it's going to be negative 12 over 5. But we wouldn't have been able to find who's negative if we didn't draw it to determine that the 12 was negative because of its placement. All right, let's go on to another example. If the tangent of A is radical 7 over 3 and sine of A is less than 0, well, less than 0 means it's negative. So now I've got to think, where is sine negative? Sine is negative in quadrants 3 and 4. And tangent is a positive 7/3. Where's tangent positive? 1 and 3. So it looks like they both have 3 in common. So that's where I'm going to actually draw this triangle, in quadrant 3. All right, this is angle A. So tangent is radical 7 over 3. Tangent, opposite over adjacent. Well, it's got to be a negative. Negative radical 7. That's got to be a negative also. Oh, that makes sense because a negative over a negative is a positive. So now I've got to find my hypotenuse in order to find cosine. It's not a Pythagorean triple, so I'm going to have to do a squared plus b squared equals c squared. So I'm going to go over to the side. A squared plus b squared equals c squared. And I'm going to have a negative 3 squared plus a negative radical 7 squared equals c squared. I can put that in the calculator, end up with 16 equals c squared. 4 is c. Since my hypotenuses are always positive, there's 4. So the cosine of A, which is adjacent over hypotenuse, comes out to be a negative 3/4. Perfect. Okay, let's go on to another example here. If the tangent of theta is 3/4 and theta is a measure of an angle in quadrant 3, so now they told us where we are. We're in quadrant 3. Find the cosecant. Cosecant is the reciprocal of sine. So cosecant is 1 over sine. Making myself some mental notes. Yes, I'm doing the video the same time as I did the last video, so Matthew's puppy is still here sleeping and snoring away like usual. So here we go. I'm going to draw it in quadrant 3. It's theta. Tangent, opposite over adjacent, is 3/4, but it's got to be a -3 because of where the position is in a -4. It's a Pythagorean triple, so this is a 5. I need to find the cosecant. Well, if the sine of theta is opposite over hypotenuse -3/5, cosecant is a reciprocal, so the cosecant of theta would be a -5/3, and this time I'm going to put the negative right in the middle because it doesn't make a difference if the top or bottom is negative. It means the whole fraction is negative. So my answer is a -5/3. Okay, 2 more examples. Here we go. If the tangent of theta is 8/15 and the secant of theta is a -7/15, find the cosecant. Well, secant is 1 over cosine, and cosecant is 1 over sine. Let's see, tangent is positive in quadrants 1 and 3. Cosine is negative because then it would make cosecant negative in quadrants, or I'm sorry, secant would then also be negative in quadrants 2 and 3, if I can remember correctly. So they both have 3 in common, so that's where I'm going to draw it, in quadrant 3. Okay, there's theta, my right angle. Tangent is 8/15, so it's a -8 and a -15 because of position. It's a Pythagorean triple, so this is 17, if you remember your Pythagorean triples. If not, you would have had to do a squared plus b squared equals c squared. Find the cosecant of theta. Well, if the sine of theta is -8 over 17, the cosecant of theta then would be -17/8. There's my answer. All right, one more example for today. Cotangent of theta is a -1. So cotangent is 1 over tangent. Let's see here. And tangent is negative in quadrants 2 and 4. Cosecant is 1 over sine. And that's positive. And sine is positive in quadrants 1 and 2. So it looks like they both share 2 in common. Secant is 1 over cosine. So I'm going to draw it in quadrant 2 this time. All right, cotangent is a -1. And cosecant is a radical 2. Got to think about this for a while. Let's see here. If cotangent is a -1, which means the reciprocal of a -1 is also a -1. So tangent, which would be opposite over adjacent, how would I get a -1? Opposite over adjacent. It would have to be a -1 here and a +1. Yep, that makes sense. And cosecant, which is sine, which is opposite over hypotenuse. So sine would be 1 over radical 2. So this must be radical 2. Okay, so secant is 1 over cosine. So cosine of theta is adjacent over hypotenuse, which would be a -1 over radical 2. So therefore, secant of theta would be a negative radical 2 over 1, or a negative radical 2. That was pretty easy. All right, see you in class tomorrow.